Today we are going to solve polynomial equations by factoring, solve radical equations, and solve equations with rational exponents. So we're working with 1.6, day 1, other types of equations. So we're going to first start with solving the polynomial equations by factoring. Okay, so we're going to start with solving by factoring and using the zero product principle. You want to make sure your equation equals 0. So I'm going to factor it. I'm going to take out a 5x squared, and I'm left with x squared minus 4 equals 0. And then I could factor this more. And then you just set each factor equal to 0. And so you're going to divide by 5, square root both sides, so x equals 0. Here x equals -2, and here x equals 2. And those are your answers. Okay, with this example, you want to move everything over so it equals 0 first. And I'm going to do factor by grouping since there are 4 terms. I'm going to take out a 4x squared, and I'm left with x minus 3. Take out a -9, and I'm left with x minus 3. So I have 4x squared minus 9, x minus 3. This one can go further. And then I'm going to set each one equal to 0. So I'm going to get x equals -3/2, +3/2, and 3. Okay, and I'll do one more. You want to set this equal to 0. I'm going to factor out a 3x, and that leaves me with x cubed minus 27. And then this is SOPs. So first you uncube it. Then you square the first term, opposite sign, product, square. And then you set each one equal to 0. Remember, you won't be able to factor this. So x equals 0, 3, and then this one we have to use quadratic formula. So you're going to get 9 minus 36, which equals -27, and that equals 3i√3/2. And then you're done. Our next concept is radical equations. And so our point is to get rid of the radical. And you do that by squaring both sides. because a square and a square root cancel each other out. And then I'm going to move everything over so I can try to factor it. Because you need two numbers that multiply to give you negative 20 that add to give you 8. So it'll be 10 and negative 2. And then you set them equal to 0. Now, the thing about these, you want to check your answers. So you're going to plug in to the original equation, negative 10, and see if it works, and 2 for x, and see if it works. So here we got 80, 20 plus 80, which is the square root of 100, which can't be negative 10, so that one does not work. Then over here we have 20 minus 16, the square root of 4, which is 2, so that one works. So 2 is our only answer. Negative 10 is what we call extraneous. So you got to make sure you check your answer. Okay, on a problem like this, you want to isolate the radical. So you want to get the radical by itself. So I'm going to move the 6. And then you're going to square both sides to get rid of the radical. So squaring this means foiling it out. So you'll get x squared plus 12x plus 36. Then you set it equal to 0. And we need two numbers that multiply to give us 21 and add to give us 10. So that has to be 7 and 3. So we got negative 3 or negative 7. And you always have to check. So first you try negative 7 in the original problem. And then we're going to try negative 3. So here we get negative 14 plus 15. 1 minus negative 6 is not negative 7. So over here we get negative 6 plus 15 is 9. The square root of 9 is negative, or 3. 3 minus 6 is negative 3. So this one works. So we only have one answer. Okay, and in this example, we have two radicals. So I'm going to move one of the radicals over. And then I still have to square both sides. Squaring means you're going to write this twice and FOIL it. So you're going to get 4 plus 2 radical x minus 3 plus 2 radical x minus 3 plus, and the radicals will cancel, x minus 3. So I'm going to combine like terms. The 4 and the minus 3 will make 1. Then I got an x. Then I got 4 x minus 3. So here again, I'm going to move everything away from the radical. So I'm going to get 4 equals, I'm going to divide by 4. Square both sides. 1 equals x minus 3, so x equals 4. Don't forget to check. So I got square root of 9 minus the square root of 1. Square root of 9 is 3 minus 1. 2 equals 2, so we're good. Okay, our last concept is rational exponents. And we're going to solve these by getting rid of the exponent. Okay, so to get rid of the rational exponent, you raise it to the reciprocal, because that way they cancel out. And remember, that means we're going to change it back to a radical. 27 is your base, 3 is your root, and you're raising it to the second power. Because it's odd, you don't need plus or minus. So the cube root of 27 is 3, and 3 squared is 9. Okay? If you have something like this, you still want to raise it to the power, to the reciprocal. So it goes away. You immediately change to a radical. 4 is your base, 2 is your root, and you raise it to the third power. Okay, because your root is even, you're going to have plus and minus. Okay, so that means that when you work it out, the square root of 4 is 2, 2 cubed is 8. So we're going to have negative 5 plus 8 and negative 5 minus 8. So your answers will be 3 and negative 13.